So if this was the second one you were doing, then you would have a look at this and you would have your equivalent circuit, and your equivalent circuit would have something probably called resistance parallel 1 and resistance parallel 2. And that would be your equivalent circuit for that network. So then using either of your methods for working out parallel resistors, whether you did the product over the sum or you did 1 over R1 plus 1 over R2 to get your RP1, your RP1 should be 6.667 to 4 significant figures. And your RP2, again using your product over your sum, or 1 over R3 plus 1 over R4. Takes you 17.14 to 4 significant figures. That would be your next equivalent circuit, and then to get your RT would just be, these are now in one current path. So now to get your R total, you would just add these. One current path means resistors in series. So your R total would be your RP1 plus your RP2. 2 seconds. That gets you 23.81 ohms. So then the next thing you're going to do is to do your IS. So it's VS over RT. So it's 40 over that 23.81. And this will be the current that you're going to divide. .68. It's 6799, so that will round to 1.68. And then you're ready to do your two current dividers. So I'm going to sketch out what your two current dividers are first. So going from your original circuit diagram, you're going to have one current divider that comes into the first parallel section. And it's the IS that comes into the parallel section, that 1.68 amps. And it'll be that IS that comes back out that parallel section and goes into the next parallel section. So this is your R1, R2, R3, and R4 with the same values, 10 ohms, 20 ohms, 30 ohms, 40 ohms. So in your first one, to get I1, which was the current through R1, IS is the current you're dividing. The opposite branch is your R2, and it's R1 plus R2 in the bottom. And that would be your working for that. So that works out to be 1.12 amps. And then for your I2, again, opposite branch R1 over R1 plus R2, those two branches added together. And that's 0.56 amps. And these two currents here, the 1.12 and the 0.56, should add up to give you the 1.68. They then rejoin, looking back at your original circuit, that IS I1 and I2 rejoin to give you IS again in here. And it's IS again that splits in this second circuit here. So it's still 1.68 amps in here. So to get your I3, IS times R4 is in the opposite branch. And you'd work that one out. That's your I3, your I4. IS times R3 is on the top branch. .68 again is the current you're dividing. And these two currents will add up to give you 1.68. So these two add up to give you 1.68, and these two add up to give you 1.68. And when you've done that, you're ready to go back and look for your voltage dividers. So when you go into the last part and you're going to do all the voltages using voltage division, you should be back looking at this circuit here again with the two in series. So you voltage divide in series circuit, so this is the circuit of interest. So if you were doing a voltage divider across that, voltage RP1, which is going to be the same as the voltage across resistor 1, which is going to be the same as the voltage across resistor 2. That's the same voltage here, same voltage here, same voltage here. Then you're going to do your VS multiplied by RP1 over RP1 plus RP2. So you're doing your voltage divider in that series circuit. So 40 is the one you're dividing. And that gets you 11.20 volts for your first parallel part. And then for your second parallel part, VRP2, which is the same as voltage across resistor 3, which is the same as the voltage across resistor 4. So this voltage here is the same as this voltage here, is the same as this voltage here. These are all the same. Again, the voltage you're dividing, looking at this circuit, is going to be your supply voltage, that 40. And it'll be RP2 in the top and RP1 plus RP2. So your RP2 you'd worked out to be 17.14. You can see that up here. .14. And that gets you 28.80 rounded. So 28.80 plus 11.20 gets you 40. And 40 is your supply voltage from back here. So that is fine. That's it complete.